representing structure formula is bond line structure. So bond line structure, in this it is the simplest way of representing the structures. This is the simplest way of representing the structures. In this only lines are used. Only lines are used. Okay. Carbons and hydrogen atoms are not shown. They are not shown. Okay. So carbons and hydrogen atoms are not shown in this way of representation. Only lines are represented. Only lines representing carbon bonds are shown, are drawn in zigzag way. That means in zigzag fashion. Atoms specifically written are oxygen, chlorine and nitrogen, etc. They are shown. And terminals, that means ends. Terminals denote methyls, CH3 methyl. Terminals denote methyls. So if at all any functional group is there, if at all any functional group is present, it is indicated. It is indicated. The line junctions denote carbon atom. The line junctions denote carbon atoms. That means only lines are used here, and then carbon and hydrogen atoms are not shown. Lines representing carbon-carbon's bonds are drawn zigzag, like this, zigzag way. Atoms specifically written are oxygen. For example, if oxygen is there, then it is shown as OH or something like that, or chlorine or something Cl like that. The terminals, these are the ends. For example, these are the ends. These are, if they are not denoted by methyl, they are just left like this. That means they are methyls. If any functional group is present, then it is indicated like this. This line junctions means this corners are nothing but they are carbon atoms. Okay. So hope you understood, students. Now let's see some examples. Let's see some examples. This is a example: CH2, CH, CH2, 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 CH2 and CH3. On third carbon we have a methyl group. Okay. So now this can be represented in bond line structure as like this. So zigzag way of representing. So if we count, this is 1, 2, 3, 4, 5, 6, 7 and 8 here. 1, 2, 3, 4, 5, 6, 7 and 8. So these joints are nothing but carbons. Here I will write it in expanded form. This is a methyl group, the terminal carbon, and here is a CH2 group, and again we have a CH on which a methyl group is present, and again a CH2 group, 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 and a CH3. 1, 2, 3, 4, 5, 6, 7, 8. So this is the way of representing bond line structure. So here there are no atoms shown. This junctions are termed as carbon atoms, and it is a tetravalence. So definitely, apart from this bonds, hydrogens are present, and this terminal ends are denoted by methyl group CH3. See, you can see here 1, 2, and 3. These are nothing but methyl groups. This is the way of representing bond line structure, and this is the simplest way of representing bond line structures. Okay, so let's see some examples. For example, we can see 2-bromopropane. 2-bromopropane. Even we can see 2-bromobutane. If we want to write this chain in bond line structure, how can we write? For example, prop means 3 carbons. So on second carbon there is a bromo group. So if other atoms other than carbons, hydrogens, other atoms can be shown. So this is the structure, bond line structure represented. So this is first carbon, second carbon, third, these are methyl groups, and 1 bromo is present on the second carbon. So 2-bromopropane. So let's see 2-bromobutane. But means 4 carbons. So this is the, so on the second place we have a bromo group. So this first, this is methyl, and we have 2 carbons here. So this is 2-bromobutane. So if you want to write this in a condensed form, then we can write like this: CH3, CH, Br, CH2, CH3. Br, CH, Br, CH3, sorry, this is propane, and this is butane, CH3, CH, Br, CH2, CH3. So this is the way of writing condensed form. Hope you can try out for the dash line structure to write about this compounds. Dash line structures to write these compounds. Now let's look at how to write cyclic compounds. How to represent the structure of cyclic compounds. So let's see bond line structures. How to represent bond line structures. So see, there is a closed structure. So 1 carbon, 2 carbon, 3 carbons, and there is a CH2, CH2, and CH2. This is a cyclo closed. So the name is cyclo. How many carbons are present? 3. So the root word becomes prop. All are single bonds. So cyclopropane. So how to represent this in bond line structures? We can represent this like this without denoting any atoms. This corner junctions are nothing but carbon atoms, and 2 bonds are here. So definitely there will be 2 hydrogens. So this is a way of representing bond line structures. So let's see another compound. Another compound is cyclopentane. So 1, 2, 3, 4, and then 5. This is 2 hydrogens on each carbon atom. As we all know, carbon is tetravalent. So how to represent them in bond line structure? So bond line structure is represented like this. This is the bond line structure of cyclopentane. 5 carbons. So this is the name is cyclopentane. So now let's see about cyclohexane. So CH2, there's 1 carbon here, 1 carbon here, 1 here, here, and then so we have on each carbon we have H2s, 2 H's, hydrogens. So how to represent this in bond line structure? We can represent this in bond line structure as like this. This is cyclohexane. Cyclohexane. Let us assume that if there is a chloro group, CH2, CH2. Here we have CH. Here there is a chlorine present on this carbon, and then CH2, CH2, and then CH2. As usual, this is cyclohexane. How to represent this in bond line structure? So we will write like this. Here a chloro group. So this is chlorocyclohexane. Chlorocyclohexane. This is the chlorocyclohexane. See the three-dimensional representation of organic molecules. So here in this 3D structure of representation has some conventions. So what are those? We should know that first. So here this in this 3D representation there is a solid wedge representation of the bond lines. There is a dash wedge representation of the bond lines. So this is the solid wedge representation. This is the dashed wedge. What does that they mean? I'll tell you. So here they depict that the solid wedge, they tell us that the bond projecting out of the plane of the paper. That means if let us assume a carbon atom is present and the bond is towards us, towards the observer. So it is out of the plane of the paper. So here, so solid wedge, this is bond projecting. This is the bond. It is projecting out of plane of the paper. That means it is towards the observer, towards us, towards observer. This dashed wedge depicts, it tells that the bond projecting out of plane of paper, projecting away from the observer, that means back. That means it is like this, projecting away from the observer. So the bonds lying in plane of the paper are shown using a normal line. So these are the conventions of writing a 3D structure. Let us see an example. Let's see methane molecule. In methane molecule, the formula is CH4. The central atom is carbon. So here, this is carbon. So one hydrogen. So the solid wedge, while drawing the solid wedge, the broader end of the solid wedge, this is the broader end, right? So this is the broader end. This broader end should face towards the observer. That means who are seeing this, they should be faced towards the observer, this broader end. Okay, so this is one, and then here see, and this is in the plane of the paper. So let's write the hydrogen. So this hydrogen is towards the observer, this hydrogen is away from the observer, this is in the plane of the paper. So this is a way of representing three-dimensional structure of organic compounds. So this is the bond away from observer, away from observer. This bond is towards the observer, towards the observer. Observer means that is the person who is looking at, and these are the lines of the plane of paper, plane of paper. So these are the four ways of representing organic compounds. The first one was dash line structure, second one was condensed, third line broad line structure, and the fourth one is three-dimensional structure. Thank you.